So very good morning, students. So welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 8th students so far for today's session. As you all well aware, and you can see on the screen, my subject is physics. We are in class 8th. Our ongoing chapter, heat, which is the last chapter of our material, chapter number 8. And probably the 1 or 2 sessions, we are going to complete this one. So today we are entering into the session number 5. That means so far we covered 4 sessions in understanding the various concepts of heat. So we'll continue where we left in the last class. But before that, let us recall, let us review what we learned in the last 4 sessions about very important applications in our day-to-day life, that is heat. So when you turn to the next slide, you can see here clearly what we learned in entire 4 sessions. The first one, we learn about what is heat and what is temperature. Now we can experience outside how much temperature is there, and because of that we are feeling the heat. So heat is the cause, temperature is the effect, which we can experience, we can feel. But the temperature can be measured by using the various types of thermometer as per our requirement, right? So that is, we discussed about what are the different types of thermometers, thermometer scales, Celsius thermometer, Fahrenheit, Romer, Kelvin, right? Then we have seen the relationship also between them. With the help of relationship, we can convert one scale into another scale also. One scale of temperature into another scale. Celsius into Fahrenheit, Fahrenheit into Kelvin, Kelvin into Celsius. Anything we can convert by using the standard relationship among the scales. After knowing about thermometer scales, we enter into the next part of heat, that is thermal expansion. So all the states of matter, as you know, there are so far 3 states of matters are there: solids, liquids, and gases. All these 3 expand on heating. Expand is what in my expansion? Change in the shape, size, volume, everything. It's called expansion. Either it may be solid, or it may be liquid, or it may be gases. They expand on heating. So we are in the process of learning about the expansion of solids and liquids. Gases will come across in your higher classes. Okay. So in that again, we have seen what are the types of expansions in solid. Because as you know that solid having the regular shape, regular geometrical shape, when compared to the liquid, solids would undergo 3 kinds of expansion. Lengthwise expansion, area-wise expansion, volume-wise expansion. Linear expansion, areal expansion, volume expansion. Or linear expansion, superficial expansion, cubical expansion. Same meaning. These are 3 types of possibilities of expansions in solids. But liquids will undergo only volume expansion, because you know liquids doesn't have any shape. They occupy the shape of the container only. So in last class we discussed about how expansion of liquids takes place. So commonly you can see at home also. When you are heating any liquid in a vessel, first we will see that the level of the liquid appear to decrease. Because heat directly strikes the solid, solid would expand first. So water level appears to be decreased. But after some time, there is a rise in the level of water. Liquids expands faster than the solids because the arrangement, so you can see the gap between the molecules is more. Of course, gases are still more. Okay. So up to that, we discussed what is the temperature, what is heat. Already we discussed about that. And so we have seen scales of temperatures. What are the different scales of temperature? Right. Three sets of scales, the relationship is there. Then we enter the thermal expansion, that is expansion of solids. We have seen linear expansion of solids, lengthwise expansion. Any commonly you can see. Then coefficient of linear alpha, beta, gamma also we have seen. So that depends on some factors. So then the expansion of liquids, as we have seen in this video also, how the liquid expand. Initially, at 4 degrees Celsius, there is special properties there for the liquid. That is called analogous expansion. Okay. Up to this, we discussed about the expansions. Now we are coming to a last part of the heat chapter. Last part, that is calorimetry. Very interesting thing. So calorimetry. It is a branch of heat. It is a part of heat. Deals about the measurement of heat. How to measure heat. Right. A branch of heat which deals with the measurement of heat is called calorimetry. So you can be understanding how to measure heat, sir. So there is a device called calorimeter. Right. Calorimeter used to measure the heat. Either heat absorbed or heat radiated. If any body absorbs the heat, it becomes hot. Any body releases the heat, it becomes cool. So those things can be measured by calorimeter. Calorimeter is a device used to measure the heat absorbed or heat radiated. So in this chapter, we'll discuss about what are the factors influencing the heat absorbed by a body, or solid or liquid or gas, and how to measure them, which is completely discussed in a topic called calorimeter. Okay. So you can see here calorimetry will start. We know that spontaneous transfer of heat is from a hot body to cold body. Heat is from hot body to hot is missing here. Hot body to cold body. If heat changes with the surrounding is negligible, then the total heat lost by hot body is equal to heat gained by cold body. Very, very important statement. This is the principle on which calorimeter works. So, for example, I already told you, suppose you have taken two bodies. One is 20 degrees Celsius, other one is 10 degrees Celsius. Both bodies are kept side by side. Right. So which one is hotter body? This one is hotter body. As we know that heat transfer from hotter body to colder body. So up to what level it changes? Up to what level? Until both becomes the same. 15 and 15. 20 plus 10 is 30. So 15, 15 they become. Until that the heat keep on transferring. Such position is called thermal equilibrium. What is called? Thermal equilibrium. But what is happening here? Hot body loses 5 degrees. It came down to 15. Whereas cold body increases 5 degrees. There is no loss of heat. But what happens? Heat lost by hot body. You can say heat lost by hot body is always equal to heat gained by cold body. Right? Cold body. Right? This is the process. Okay, this is about on this principle only entire calorimetry works. So before going for the further explanation, so let me show you one video on this calorimeter. Then we'll move to the further explanation and mathematical derivation of the calorimetry. Right? Just have idea about what is calorimeter.
Here's a familiar scenario for many of us. You purchase your favorite junk food and demolish the entire bag or box in one sitting. Just out of curiosity, you take a glance at the nutrition information on the back of the package, and your full stomach drops. It turns out that you just ate more calories with this one snack than you should in one day. Have you ever wondered just exactly how the manufacturer of the food item knows how many calories it contains? Thanks to calorimeters, manufacturers are able to tell us exactly how many calories we're consuming when we eat their product. A calorimeter is used to measure the enthalpy, which is the heat energy of a reaction. Calorimeters can vary in quality. Simple calorimeters are used in high school chemistry classrooms, but much more sophisticated calorimeters are used in industry. There are many uses for many different types of calorimeters. We'll discuss two of the most common calorimeters and their uses. 1. Coffee cup calorimeter. A basic coffee cup calorimeter typically consists of a styrofoam cup, an insulated lid, and a thermometer through a hole in the lid. It's typically filled with water. Calorimeters measure the energy transferred between the water in the cup and an object that's placed into the water. Coffee cup calorimeters are often used in high school chemistry calorimetry labs. A specific mass of water is poured into the styrofoam cup, and the temperature of the water is recorded. An object or substance is quickly placed into the water, and the lid is replaced. After a minute or two, the temperature is measured again. This change in temperature can be used to find the enthalpy of fusion, the energy required to freeze or condense, enthalpy of dissolution, or the specific heat of an object, the amount of energy needed to change the temperature of 1 gram of the substance by 1 degree Celsius. Each substance has a unique specific heat. A limitation to this type of calorimeter is that styrofoam is not.
Okay. There are some more are there. One more video is there.
And this is Chemistry Essentials, video 51. It's on calorimetry. And like anything in chemistry, a lot of this can go back to Antoine Lavoisier, that brilliant chemist who started a lot of modern chemistry. And so calorimetry, if we just break down that word, it means the measuring of heat. And the first calorimeter that was created by Lavoisier was an ice calorimeter. And basically what you had was a chamber that had ice on the inside, and then an insulating chamber of ice around the outside of that. And then you would put something inside the calorimeter, a candle, for example, and what would happen is it would generate heat as it's doing combustion. It would melt the ice around it. That ice would turn into a liquid, which he could measure. So you could measure the amount of energy that's being released from the candle. He then put something living inside there. He used a guinea pig to start, and what he found is that it occurred in the same way. In other words, that guinea pig is doing respiration, which is a form of combustion. It's using oxygen, it's releasing heat, and he showed that this is essentially the same kind of a process. Requires oxygen, gives off carbon dioxide, and so what he's really looking at is the energy given off by this system. And so a calorimeter is pretty simple. It only has two parts. It has a heat bath around the outside, and that generally is made of water because we know specifically how water changes over time. And then you're going to have a chemical system that's placed inside of that. We need a thermometer inside that heat bath so we can measure what's happening as we get changes of energy within it. And so we can measure energy change from that chemical system. And we could use this to measure everything we described in the last video. The specific heat capacity, the enthalpy of fusion and vaporization, and also the enthalpy of the reaction. And so let's start with water. Imagine that we have a beaker of water and we're adding energy to that. Remember, we measure how easily it's heated or cooled using a measurement called specific heat. And so if we break down that equation, specific heat is equal to the quantity of heat transferred, and we're going to measure that in joules, divided by the grams of the substance, in other words, how much we have, times the temperature change. And so let's give you a real example, because we know specifically what the specific heat is of water. It's 4.18 joules per gram Kelvin, and that's been well established. It's going to be important that we understand that as we start to do some calculations related to calorimetry. And so imagine we have 250 milliliters of water. Now what's interesting about water is we know immediately that we have 250 grams of water, and we started at 18 degrees Celsius. And so our mass is 250 grams, and our initial temperature is going to be 18 degrees Celsius. And let's say we heat it up. And so over time it changes, and at the end it's 65 degrees Celsius. And so our final, our T sub F is going to be 65 degrees Celsius. And so what we can do is figure out how much energy was added to that water, and we're going to use specific heat to do it. Again, specific heat is equal to the quantity of heat transferred divided by the grams times the temperature change. And so let's just start working down these values right here. Well, we know specific heat of water is going to be 4.18. We now know what the mass is. That's 250 grams, so I'm just going to plug that in right here. We also know the temperature change. So we're going from 18 to 65, and so we just take our final temperature minus our initial, and so that's going to be 65 minus 18. That's going to be 47 degrees Celsius. We do some simple algebra. In other words, I'm just going to multiply both sides by this, and so I'm going to move it to there. And now I just simplify, and I'm going to find that the quantity of heat that was transferred is 4.91 times 10 to the fourth joules. And so where did that energy come from? It came from the heating of that water. And so if we know how much the water changes in its temperature and we know its mass, then we can figure out how much energy is released. And that's really how a calorimeter works. All you have is you're going to have a vessel where we're going to have that reaction or that heating or that phase change occur. And then we're just going to have it sitting inside this heat bath. We can measure the changes in temperature. And by measuring the changes in temperature of the water, we know how much energy is being released from that vessel or being consumed by that vessel. And so if we heat up that material in there, let's say it's a chemical reaction, and we see changes in the temperature, we know how much of that is coming from the reaction inside that vessel. And so this is what this would be a bomb calorimeter, and what it's doing is we're putting whatever we want to study inside this vessel, we're enclosing it inside water, we have a really detailed thermometer on the inside. Lots of times they'll have a stirrer so that we're moving that water around, and we can measure energy changes. We could use that to measure specific heat capacity, enthalpy of fusion, that's when we're going, remember, from a solid to a liquid or backwards. We can measure enthalpy of vaporization as we're going from a liquid to a gas, or we can just measure that enthalpy of reaction. We can measure endothermic and exothermic reactions. And so that's the role of a calorimeter. And so could you design or interpret the results of an experiment? Again, what we're looking at is changes in the water, and then we can work backwards to figure out how are those changes coming from that vessel, and I hope that was helpful.
Right. So this is completely about what is the calorimeter here we have seen. So calorimetry is a branch of physics or branch of heat which deals with about heat. Okay. Whereas calorimeter is a device used to measure the amount of heat absorbed or heat radiated or heat released. So during that we come across few terminology. That is, first we come across what is specific heat capacity. Suppose calorimeter is nothing but it is a copper vessel. It is a vessel, copper vessel filled with water up to certain level, right? It contains the contains two holes, lid with two holes, and placed in a wooden box, completely in a wooden box, right? It's a wooden box. And this wooden box, between the vessel and wooden box, is completely filled with the cotton or jute or wool. Either it is a cotton or wool or jute. Why? Because not to allow the heat to go outside. Completely to stop the heat to go outside, we completely surround it tightly. From one hole, we will pass thermometer to measure the temperature time to time. And through one hole goes one stirrer like spoon to distribute the heat. This total setup is called calorimeter. To measure a calorie, that is heat absorbed or radiated by a liquid. We can use this. In case of solids, there is a different bomb calorimeter will be there. Okay, this is completely by either you can use to measure the calorific value of water, alcohol, any liquid. So this heat radiated, how much heat is emitted by the body or absorbed by body, mainly depends on two factors. One is directly proportional to mass, and second, this is the first one, that is the heat absorbed or radiated by a liquid or solid directly proportional to mass, how much quantity of mass you are taking, and it is directly proportional to even change in temperature also. First, what is the initial temperature? What is the final temperature? So these are the two important factors from which you can write it as combining 1 and 2. You can write Q is directly proportional to M delta T. We can write directly proportional to mass and directly proportional to change in temperature. So to remove the proportional symbol, use the constant M S delta T. So S is the commonly used, that is proportionality constant, which is called specific heat or heat capacity. So from that we got a formula. S in place of S is taken C, no issue. MC delta T, where C is called the specific heat capacity. What is C? You can write C is equal to Q by M delta T. You can write, na? From this you can get the value unit for the C also. Q is calorie, heat is measured in calorie, mass is measured in gram, and temperature is degree Celsius. Or you can write kilocalorie by kg Kelvin also. Unit for the specific heat capacity, that is given here. Joule, even kilocalorie can write joule also. So the amount of heat required to raise 1 gram of substance to 1 degree Celsius is called as specific heat capacity, right? Which can be measured of any liquid or any solids by using the either calorimeter or bomb calorimeter, which are used to measure this particular value. So units also you can see, that is Q is equal to MC delta T, very important formula, or MS delta T. Some books they'll show S also, where C or S is nothing but specific heat of that particular. What is specific heat? What is the amount of heat required? Suppose you have taken water. Initially it's 10 degrees Celsius. If you want to raise to 11 degrees Celsius, how much amount of heat is required? How many calories of it is required? Or how many joules of it is required? Is called specific heat of that particular liquid. For different liquids, we have different specific heat values. For water, it is one only, 1 gram per cc. Okay. Then, after knowing about specific, next one is specific heat of some other substances is given here. Ice, 2140. Glass, 671 joule in MK system again. Right. So these are the values for some. So specific heat capacity of the materials is equal to the heat required to raise temperature of unit mass of substance from 14.5 to 15.5. That is 1 degree Celsius. Specific heat for what? H2. Hydrogen is maximum. Right. That is 3.5 calorie per grams. And minimum for radon and actinium. Different elements there. So specific heat of upon the state of the substance. For example, for water it is 1 gram per Celsius. For ice it is 0.5. And for steam 0.47. Same state only, but we see how the values are changing. Right. In terms of kg or gram, it is, suppose we go to moles. If you measure in mole, that is number of molecules, it is called molar heat capacity. That we'll see next. Okay. So same only formula given, C is equal to Q by delta T when there is no mass is considered. Some more words comes here. That is water equivalent and latent heat. Latent, what is latent? Latent is nothing but hidden. Hidden. We cannot find it. We cannot find heat, but a constant temperature, there is a change of state. At constant temperature, a body changes its state from solid to liquid or liquid to vapor. That constant temperature is called latent heat. Latent heat may be to convert into liquid, latent heat of fusion, or latent heat of vaporization. Two types of latent heats are there. That is boiling and melting. Melting is nothing but solid to liquid. Boiling is nothing but liquid to vapor. So these all changes takes place at constant temperature. When you keep heating the ice, a particular thermometer you can keep. When it raises certain temperature, there it will stop. Where the temperature is stopped, that place the solid is converted, ice is converted into liquid. That constant temperature is called melting point of ice. You keep continue heating. Again, temperature will rise, go to up to 100 degrees. At 100 degrees, there won't be any change in the temperature again. At that 100 degrees, the liquid convert into vapor. These constant temperatures where a state of matter either changes from solid to liquid or liquid to gas is called latent heat. If it is converted from solid to liquid, it is called latent heat of fusion or melting point. If it is converting from liquid to vapor, latent heat of vaporization or boiling point. Right? Then calorimeter. Just now we have seen what is the happens. With the help of calorimeter, what is the principle of calorimeter? Heat lost by hot body is equal to heat gained by cold body. On this principle only, the total calorimeter works. So by using that, we can solve so many mathematical formulas and we can get the values of the calorimeter, specific heat values of so many liquids also you can find out. Right? So either you can take the liquids, you can take the solids. When you go to higher classes, we'll come across all these things. How to measure the calorimeter. In 9th class, 10th class, you can solve some problems also by using Q is equal to MC delta T. There are a few examples also given, work out examples. Okay. So that we'll discuss in the next class. Almost the completed syllabus is almost completed. Maybe maximum one class will go for some solved examples on this particular heat chapter. Then the remaining classes will go for the revisions and we're done with the, okay. So now now it's a ball is in your court. You have to practice more. So we have provided you so many worksheets also. Recently, you can ask from your teachers around 15 worksheets. Each worksheet contains 60 questions. Means almost 900 questions in entire physics, maths, and biology and chemistry. You can take out and practice them, which is helpful for you. Even along with that, you completed 7 tests also. The test papers also you practice, so that next month we'll have the grand test. You can appear with the confidence. So many worksheets are given, and 6th, 7th, 8th, 9th, all classes separately given. You can correct from your teachers, in charge teachers, and practice them. Take out the printout if possible. Practice them along with our 7 test papers. Definitely you are going to get the very good marks in the grand test, which is in March month, end of the March, right? So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.